So hello, in this video we're going to learn about composite functions. Composite functions and perhaps domains, and if time allows us, of course domain goes alongside range, and if time allows us we also need to do inverse. So this is a common area in calculus that you'll find, especially calculus 1, and you'll find being tested as one of the key areas. So what is a composite functions? A composite function is a function that is composed of two functions merged together in a different way, in a way that the two functions form one function. How? For instance, we're given f of x is equals to ax plus b, then given g of x equals to my plus d. So a composite function, which normally takes the form f of g or g of f, which take the form g of f or f of f or g of g. So all these four are composite functions, and we can also, these are composite functions of only two functions. We can also have f of g of h of f, there's f of g of h, f of h of g, depending on what combination. All these, as long as those three functions or those two functions have been combined together to form one single function, then that's a composite functions. So this is a very common area in calculus, and I'll want to take this opportunity to teach you guys. So and in line of teaching you, I'll post a question. There's a question from the University of Nairobi. So the question says that, and we'll solve it together. So let me post it. So this is the question. So now you've been given this as a So you've been told to solve this. This is calculus 1 paper. You've been told to, you've gone into an exam and you've seen this. You're asking yourself, how do I solve that? So first of all, you notice there's f of x, there's g of x, and then there's h of x. So three functions. So here we can have a composite function of a combination of three functions. So we can have these. Then the other thing is we need to do a domain of a function. We do need to do a range of function. Then the composite functions of g, you need to find them, and later on we need to get the inverse. So we'll solve this in this video and perhaps explain the main areas that are normally tested in this area. So first of all, we need to know the rules of domain. So let's know the rules first of finding a domain. So in a domain, it's all about all the points on the x-axis, where the function is defined. So normally when you hear the word domain, just know that it's simple. It comprises of all the x points where the function is defined, or on the other way around, you can say you can also give it in the form of where the function is not defined, where you say it's not equal to. So let's do the function of the domain of f. So we've been given the function f of x equals to 1 over x minus 4. So where the biggest question we should ask ourselves, where is this function not defined? And by not defined, and the word not defined in mathematics simply means 1 over 0, and this mostly this is indefinite. And that's why if you write it in your calculator, you see a math error. So we need to find all the points where this function is defined or not defined. You can give domain in two ways. You can either give the other way around, or you give in where the points, all the points where the function is not defined. So what this simply means is that in this case, we are trying to find points where f of x is not defined. So let me explain a point. So this is this. So when the denominator, in this case, let me just call it denominator. Of course, it's a denominator. So just some few rules how to find domain. So when the denominator is not enclosed in a root, then the rule is that n, if it's 1 over n, then the rule is n should not be equals to 0. But if you're given 1 over a root n, you see, now that we know that a function, a square root of a function can be 0, what it simply means you can get the domain in two ways. One, the square root of n should not be equals to 0. That's the first point. Should not be equals to 0. The second point is whatever is enclosed inside n, for it to be 0, n cannot be less than 0. Or what it means that n has to be greater than 0, or the other way around is n has to be what? Positive. Has to be positive. So these are the rules. Some of the rules so let me just also add something. So these are the rules. So for the other rule behind domain is that anything x power n, any polynomial, sorry, the space is not enough here. So any polynomial of any degree always the domain is a set of all real numbers. Always. You see something like x squared plus 1, I don't know, my something plus 6x, just don't even bother. As long as you see it's a polynomial and it's not in a how do you put it, in a quotient, just always know the domain is always the set of all real numbers. So in other words, they give it in terms of what? So a set of all real numbers, at times they can give it in terms of what? In terms of an interval. It is negative infinity to infinity. So otherwise, the rules are just, I think, 3 or 4 maximum. Yeah. So unless you're given out trigonometric functions, which now I'll set some other time and discuss it in depth, because now that's where the catch is. Now, back to our question. The question states that we are supposed to find what? The domain of f of x. So how do you find that? Let's see. Let me just create some space here. I can actually delete some stuff here. Yeah. So we are supposed to find the domain of the function f of x. And perhaps, I'm sure, the next thing that comes is sometimes where you normally, so let me do this example and say, so given that f of x is 1 over x squared minus 4. So you're told to find the domain of this function. So how do you do it? How do you do that question? So this is, of course, as we said in the rules, is that the function will be defined when and only when this is not equal to 0. Therefore, x x squared minus 4 should not be equals to 0. This is x minus 2 into x plus 2 should not be equals to 0. Equating this, equating each unit to 0, so x minus 2 will be equals to 0. This implies that x equals to should not be equals to should not be equals to just a minute, should not be equals to 2. That was on the first round. The other one, we can just equate it here. So x minus 2, plus 2 should not be equals to 0, which implies that x should not be equal to negative 2. Therefore, x should not be equals to negative 2. So we have 2 points on the number line that our x cannot be defined at. Our function cannot be defined at. So how do you represent that in a number line? So what you do, so let's draw a number line. So we have, this is negative infinity, this is infinity. We have our 0 here. So we have 2 points. We have one here at 2, then we have the other point at negative 2. So we are saying that